All right, pre-calculus 12, here we go. We're going to put it all together here. Video 23, we're going to solve exponential and logarithmic functions. So let's get after it. So here we go. We now have the tools in our arsenal to solve these things without necessarily relying on getting a common base and then comparing my exponents. Because in this case, yes, we could do it. But let's look at it using logs, okay? Just to show, for this one, we'll show both. Yes, I know that 81 is 9 times 9, which means 81 is 3 times 3 times 3 times 3, which means I have 3 to the power of 4, and I have 3 to the power of x. So yes, my base is the same, my exponents must be the same, x equals 4. So that is how we did it when we had exponents, but now we also have logs at our disposal. So the first thing we would do is we would change it to log form. So log base 3 of 81 equals x. And then we know that 81 is 3 to the power of 4. We would then use our power rule to bring the 4 down. So 4 log 3 of 3. And then we know that the log of the same base and the same object cancel out. So again, boom, log x equals 4. So we get the same thing. So same result. You could have done this a couple other ways as well. You could have used a power rule. You could have taken the log of both sides. You got lots of different ways to attack this. Have a look at the notes because there's another way to do it there. I'll do that method here for the 2x equals 27. You could start an equation off, much like how you could multiply both sides of the equation by the same thing. We can take the log of both sides. So we can actually go, okay, how about the log of that is equal to the log of that. We've kind of logged both of them. Because what we can do now is we can bring the x down. And now we get x log 2 equals log 27. Now, log 2 is fully reduced, but log 27 I can break down to log 3 cubed. So now I have this. And now I have x times log base 2 equals 3 log 3. Now the only thing left I can do here is to divide by log base 2 on both sides. And in this moment, the only thing you have left to do is plug this into your calculator. And that is why we have things in log base 10 when we can, because now we have 3 times log 3, and we divide it by log 2, and we get approximately 4.75. So you need to be able to manipulate your logs in order to get them to a place where you can input them into your calculator for a little bit of additional computation. So what else we got? Okay, solve for the unknown. Now, before we dive in, let's just also include our domain restrictions here. So we are not allowed to have that object of our log be greater than 0 or less than 0. So that means x is going to have to be greater than 3. And then for this log, x has to be greater than 0, right? We need to satisfy all of them, kind of like we did in pre-calculus 11, where we solved radicals. And even in this grade in section 4, we solved some radicals. So making sure that your domain restrictions cover every potential radical. Here they cover every potential log. So the only one that actually matters is this one. And we don't have to worry about our base because our base is base 10. I don't have an unknown in my base. So what are we going to do here? Well, we can combine these logs. Same base, we're adding. So what do we get? We get log of x minus, log of x minus 3 times x. And now that all equals 1. So what do we get from here? Well, we get a question. What do I do? What do I do? What do I do? Well, let's convert to exponential form. Base is 10, so now I have 10 to the power of 1 equals x minus 3 times x, which means I now have 10 equals x squared minus 3x, multiply that x in, which means I now have 0 equals x squared minus 3x minus 10, and now I am solving a quadratic. So I get 0 equals x minus 5, x plus 2, so x equals 5, x equals negative 2. Those are my two potentials. But if you go back to your domain restrictions, we have to reject that one. So we keep x equals 5, and we solved our logarithm. So what do we do? Well, we use product rule, combine them. And the reason why we combine them is because we can then use our exponent log relationship to convert to kind of free up the x, what we need to solve. And that's what we did here. Then we water bond, and then we solved a quadratic. So we're kind of relying on a lot of our rules from as we came and went over the last few years. So let's look at another one. So now in this case, we got all base 3 logs. So again, we can use our rules. And what you'll notice is this log is just hanging out over here by itself. And to be honest, product rule is a lot easier than quotient rule because it removes denominators. So why don't we add this whole thing to that side, because it'll cancel, and we'll add it over here. Because now what we get is we get log base 3 of x plus 12 equals log base 3 of x times x plus 2. Now, if you remember your exponent laws, how we had, 2 to the x equals 2 to the 3, and if those are the same, we could just compare the exponents. Same with logs, right? If you have a log of the same base, and they have two different objects, well, then we just compare the objects. They have to be equal as well. It's the same principle. So we get x plus 12 has to be equal to x times x plus 2. So that's x plus 12 equals x squared plus 2x. Let's get everything on the same side of the equal sign. So minus x minus 12 minus x minus 12. And we get 0 equals x squared plus x minus 12, which simplifies to 0 equals x plus 4 and x minus 3. So what do we get? We get x equals negative 4 and x equals positive 3. Now, let's go back to our domain restrictions. The most important domain restriction to consider from the very beginning is this one, because that one alone tells me that x has to be positive. And I have a negative answer here, so I'm going to reject that. Now let's just check our other two. X plus 12 has to be greater than 0. Oh, well, that just says x has to be greater than negative 12. Well, that's already covered by that domain. And the other one says x plus 2 has to be greater than 0. Oh, and that's x has to be greater than negative 2. Again, covered by that domain. So this works. This satisfies our domain. We keep it, and that is our solution. So you get the hang of it? I hope. Well, let's do another. All right, so where to begin? Now, I want you to get in the habit of trying something, because you can always try. You start using your rules however you feel most comfortable with, and you'll see you'll come to a roadblock, or you'll come to something that's a little bit more challenging than it probably should be, and then just reset and start again. When you're trying to solve for a value, it's generally going to be handy to put those back as exponents. But let's quickly just look at our domain restriction. So that object of the log there means that x has to be greater than 0. But this object means that x has to be greater than 1. And this one again is x has to be greater than 0. So this is the only chunk of our domain that matters. So let's keep that in our back pocket. So the first thing I'm going to do, I'm going to take this and I'm going to put it back as an exponent. So now we have log base 3 of x squared plus log base 3 of x minus 1 equals 1 plus log base 3 of 2x. Now, if you got a whole bunch of logs, let's try to get them all on the same side of the equal sign so then we can combine them at our leisure. So I'm going to subtract log base 3 of 2x from there and from the left. So now we have log base 3 of x squared plus log base 3 of x minus 1 minus log base 3 of 2x. All of that equals 1. So now let's do some combining. So here I'm adding, so I'm going to end up with log base 3 of x squared times x minus 1. And then I'm subtracting, so over 2x, and that equals 1. Now we can simplify. We got an x in our denominator, and we got x squared, so we'll just get rid of the x squared. Now it's just an x. So now that gives us log base 3 of x times x minus 1, which we will combine, just do it in a minute, over 2, and that equals 1. So now we have one object. It's a big one, but we have one object, we have a base, and we have a solution. So if we convert that to an exponential, we get 3 to the power of 1 equals x times x minus 1 over 2. Multiply both sides by 2, and now we have 6 equals, multiply that in now, x squared minus x. Those two's canceled. So now let's simplify this, and we have x squared minus x minus 6 equals 0. Again, we're back in the land of quadratics. You get x minus 3, x plus 2 equals 0. And that gives us x equals 3. X equals 3, and x equals negative 2. And remember that that domain restriction has to be satisfied. So goodbye negative 2, and the answer is x equals 3. Alrighty, so let's keep going. Look at some more one. Okay, so here's solve for x. All right, well, what do you think? Should we take the log of both sides? Perhaps. Should we simplify anything that we can? Can we change this to 10 squared? I mean, is there a point? No. Okay, so that's the idea. Think, what should you play around with? What should you try? Well, why don't we actually convert this statement into a log form? Because even though you see log here, it's not in log form. So here's the base of my exponent. So it becomes the base of my log. Here's the answer. So this becomes the object of my log. And then I end up with log x. Now be careful here because you have two different bases, right? This is base 10 and this is base x. And also now if we look, remember that if that is in the base of my log, then that means that x cannot equal 1 and x has to be greater than 0. Well, let's see what happens here. What can we do? What can we do? Well, we can do change of base log here. So now we have log, and let's just go to base 10 of 100x over log base 10 of x. So that's nice because now that x is freed up from the base. And now that equals log x. And now here's something we haven't explicitly seen yet, but we're going to multiply both sides by log x because cancel, cancel. But then we're going to multiply this by log x. Now this is a rule that you haven't seen because it's not a rule. Multiplying two logs together just gives you log x all squared, right? Log x times log x. And now that equals log of 100 times x. Now, what I want you to be careful with is that this does not equal this. Okay, no, it doesn't equal that because that's not in the object of the log. So be careful there. That's another pretty regular pitfall. So what are we going to do? How are we going to tackle this? Well, first let's separate this product into log base 10 of 100 plus log base 10 of x. And now again, we have log x squared. Now, if you look closely, log base 10 of 100 is 10 squared, which means you have 2 log base 10 of 10, which cancels, right? Because same base, same object. So now we just have 2 plus log x equals log x all squared. Now, here comes the sneaky, I don't know, not intuitive, but piece of substitution where you recognize that maybe you have a quadratic hiding in here. So we could say, why don't we let log x be equal to z, for instance? Because now what do we have? We have z squared equals z plus 2, which means we have z squared plus, or now, minus z minus 2 equals 0. So I've rearranged my quadratic, right? And now I can factor this to z minus 2, z plus 1. Now I'm just going to erase some of the stuff here on the left because I need a little bit more room to write. But you can always hit rewind. See that again. Because what do we have now? We have a quadratic, right? And we have a quadratic where we get z plus 2 equals 0, or sorry, when z, not plus 2, z minus 2 is 0, so that means z equals 2, and we have z equals negative 1. But what was z? Z was log x. So either log x equals 2 or log x equals negative 1. Now you might be thinking, well, I still don't know what x is, but we can do change of base. We have, or not change of base, we can convert to exponential. We have log base 10, so we have 10 to the power of 2 equals x, which means over here on the right, x equals 100. And we have 10 to the power of negative 1 equals x, which means way over here on the right, x equals 1 over 10, or 0.1. So here we have a lot of stuff happening, right? So watch this one again if you have to, but we end up, this is the trickiest part, be aware of that. It's nicely outlined in the notes for you as well. So again, you're not always going to get thrown nice softballs, right? You're going to get some curveballs sometimes. You got to be able to adapt, and that's the challenge. So let's keep going. We got a couple more to go here. So solve for x. Now, here we have an exponential statement, and if you need to free up exponents, you're going to want to use logs. So when you can, if you can, take the log of both sides. But be wary here because that's 3 times. So now we're going to take the log of this whole statement, and we're going to take the log of that statement. And now what we'll do is we'll do product rule here on the left. So now I have log 3 plus log 2 to the power of x minus 2. And then that equals log 6 to the x. And now we will use our product. So from our product rule, remember that we can bring, or it's not our product rule, our power rule. We can bring our powers down to the front. So now we have log 3 plus, in brackets, x minus 2 log 2 equals x log 6. And why are the brackets important? Well, the brackets are important because it's log 2 times all of that. So now it's log 3 plus x times log 2 minus 2 times log 2 equals x times log 6. So there's lots happening here, but you'll notice we have 2 x terms and 2 non-x terms. So what can we do with this? Well, let's get our x terms together. So I'm going to subtract log 3 from this side and add 2 log 2 to this side, because that's going to get rid of it there and there. But that means I'm going to have to subtract log 3 from this side and add 2 log 2 to that side. And then at the same time, I'm going to subtract this from both sides. So what do I end up with? I end up with x log 2, now minus x log 6. Now I don't have room here, so equals 2 log 2 minus log 3. So now we can factor out the x. So we get x times log 2 minus log 6 equals, and now here, this 2 can go back into our exponent and we can just make it log 4 because it's a calculation we're going to make. So equals log 4 minus log 3. Now remember, we need to make some calculations here. So this statement here can be put back together, and this statement here can be put back together, and you get x times log 2 over 6, right? Because we are subtracting the logs, equals log 4 over 3, because we are subtracting the logs. 2 over 6 can get simplified to 1 over 3. So now, but we can do that after. So now we divide both sides by log 2 over 6. So you get log 4 over 3 over log 2 over 6. And then, yeah, you could simplify that, but you can also just plug this into your calculator. So if you go log 4 over 3, and then go divided by log 1 over 3, or 2 over 6, whichever you prefer, you'll get the answer in a decimal of negative 0.26. And obviously it continues, so you round slightly. But you could also leave your solution here. You could leave your solution a little bit more simplified with your fraction. And then you'll see in the notes that there's also one more example of how you can further simplify your log, but I'll let you look at that on the notes. So now we got a couple more, and these ones get a little bit more abstract, and it's all about putting our rules together. So we want to solve for a, which means we need this a all by itself. So first, the goal is going to be, can we get log a alone as, or at least log the log as one object, because then we can use our exponent to log conversion. So first thing I'm going to do is I'm going to take this 5 and I'm going to put it back up to a power. So now I have log a to the 5 minus 2 log b equals c. Now I'm going to take the 2 and put that back to a power. So I have log a to the 5 minus log b squared. And now I can put these back together. But why would I want to do that? Remember, what's our goal? Our goal is to solve for a. But I put them together so I have one log object. So now I have log a to the 5 over b squared all equals c. And I do that because now I can put everything into an exponential. I have log base 10. So I have a base 10 exponent to the power c equals a to the 5 over b squared. And now I've done that because now my logs are gone, and now I can get a alone. So now I multiply b squared on both sides, and I get b squared times 10c equals a to the 5. And then how do I get rid of that a to the 5? Well, I fifth root both sides. So a equals the fifth root of b squared times 10 to the c. And I can't simplify that any further. That is my solution. Very nice. So this is our last one. It's a pretty regular example. Now, if log 3 equals a and log 8 equals b, what's log 18 in terms of a and b? Well, we're kind of working towards getting log 3 and getting log 8. So what do we have? Well, log 18 breaks into log 9 times 2. Great. Log 9 times 2 becomes log 9 plus log 2. Awesome. Now, 9 is 3 squared. So now I have log 3 squared plus log 2. Okay, well, I'm making progress because now I have 2 log 3 plus log 2. Now, log 3 I know is a, so I can simplify this equation and I'm halfway there. I have 2a, because that's what log 3 is. But I have log 8. Well, how do I get log 8 from log 2? Well, log 8, hey? Think about 2 and think about 2's relationship to 8. Well, 2 times 4 is 8. Okay, can't really do much with that. 8 divided by 2 is 4. No, 8 divided by 4 is 2. Okay, but remember, I only want one number. I want the number 8 once. These will all give me weird product or weird quotient rules. But what else about 2? What's 2 to the power of 3? 8. So we can write log 2 as log 8, but cube rooted, because the cube root of 8 is 2. So that right there is equal to 2. But I have it now in terms of log 8. So I have 2a plus, bring the exponent down, 1 over 3 log 8. And now log 8 is b, so I can simplify this to 2a plus 1/3 b. So there's sometimes some fancy footwork. Remember that other example, I turned 2 into 10 divided by 5. In this case, I turned 2 into the cube root of 8. So sometimes you got to maneuver in ways like that in order to make things connect the way you want them to. So that was the last one. There's a few in your notes, and again, a workbook full of practice questions. So I strongly suggest you try as many of these as you can to get as comfortable as you can with your different log rules. And hopefully it will all come along relatively quickly, but it's going to take some practice. So don't get frustrated. When in doubt, ask. Always reach out if you need some support. Okay, thanks so much, and see you next time.